Hi students, welcome to your math lesson of the day. Let's go over the number form of the day today. So yesterday was Wednesday, so today is going to be Thursday. Woo! Today is Thursday. Period. And we are in a new, this is the start of a new year, so we are at the first month of January. So we'll write number 1 for January. And yesterday was the 6th in January, so today is going to be the 7th. And then instead of the year of 2020, we are in the year of 2021. And most people put either the full year, so 2021, or the last 2 digits of 2021. And here's like another way you can write the number form of the date: 1/7/2021. But those are 2 different ways you can write it. Okay, so I'm going to clear my screen, and I'm going to go over the clock for one brief moment. So this will be a little quick exercise on the time. 4, 5, 9, 10, 11. So on an analog clock, we know that there's 12 numbers on the clock, and there's 2 hands. So there's a longer hand that represents the what? The minutes, and then the short hand represents the hours. So for this example, I'm going to say the long hand is going to be blue, so the minutes are going to be blue. And then the short hand is going to be hours. So if we look on the clock, the green hand, which is the hours, the short hand is the hours. But the hours are very easy, because when the shorthand is pointed to a number, it's going to be that number. So it's going to be 3 and something. And now we have to figure out the minutes. So even though the long hand, the minutes, is pointed to the 7, we have to count by 5s until we get to 7. So 12 is 0. So if we count on 12, 5, 10, 15, 20, 25, 30, 35. Oh, I messed up my clock just a tad. But on this brief clock example, it's going to be 3:35. Okay, and we'll get more practice with this, so you guys can automatically know that the shorthand is the hours and the longhand is the minutes, and the longhand represents by 5. So even though it's pointing to the number 7, it's going to be 35 minutes, because you have to count by 5 7 times. Okay. We are in chapter 4.5 in Big Idea, so we're learning to add 3 different add-ins to get one answer, one sum. So I'm going to go over a brief example real quick. So for this example, we have 4 plus 2 plus 8, and we're trying to figure out the answer. So I'm going to show you guys 2 different ways you could solve it, or 3 different ways. So it doesn't matter however that you add the numbers. You can add the 4 plus 2 together, or the 2 plus 8. But if we add the 2 and the 8 together, what number is that? So if we go over here, we have 2 dots. And if we count 8 dots, 1, 2, 3, 4, 5, 6, 7, 8. And if we count the total amount of dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. So 2 plus 8 is going to be the answer 10. But we can't forget the number 4, can we? So we have to add 4 plus 10. So if we add 4 plus 10, we can do another dots example. We could do 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can count the amount of dots to equal the total answer. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have the answer of 14. And if you want to double check your work, you can even add 8 plus 4 or 2 plus 4, and then add the remaining add-in left over, just to double check your work to see if you still get the same answer, which is pretty neat in math. But for this example, we have 14. But let's try a different example. So we have 4 plus 3 plus 7 equals blank. So last time we did the dots method, we can use the number line for this example. So I'm going to draw a number line. And since my screen is not super long, I'm going to start with the number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And we'll just pause on 18 because I don't think our answer is going to be over that. But if we could look on the number line, we have the number 7, we have the number 3, and 4. That's what we're trying to solve. But if we put a dot on the number 7, if we were adding 3 and 7, if we go up, and since we're adding numbers, we're moving further away from 0. So we're going to go up towards 18. And we're going to go up 3 times. 1, 2, 3. And we have the number 10. So now we have 4 plus 10 equals it's going to be our answer. So now we have to go up 4 more times. 1, 2, 3, 4. And we also have the answer 14. And you can even do 4 plus 3 just to recheck your work as well. Okay, now let's do another brief example. So in your Big Ideas textbook, you see 9 plus 1 plus 5 equals blank. So you see the number 10. So which add-ins in this example make 10? If we add the 1 and the 5, that's going to give us the answer 6. But if we add the 9 and the 1, we get 10. But now, since we add the 9 plus 1, now we have 10 plus 5 to make things easier. And what I like to do, since there's no number in front of the 5, see, I'm going to rewrite this problem so you guys can understand me better. So I'm going to write it like this. There's nothing in front of the 5, so 5 is one number and 10 has 2 numbers. So we're going to pretend like 0 is in front of the 5. So we add 0 plus 5. We know 0 has no value, so if we add nothing with 5, we're still going to get 5. And the same thing with 1. Since 0 has no value in front of the 5, we just get 1. So 10 plus 5 is going to be 15. So 9 plus 1 plus 5 is going to give us the sum of 15. And you can also check your work using the number line. You can use it by doing the dots method. You can count with your fingers, but there's multiple ways that you can find your answer in math, which is why math is one of my favorite subjects, which is why I mention it a lot. But if you have any questions about adding with 3 numbers, and if you want more practice, that's what my office hours are there for. So don't be afraid to message me because I am happy to help you out to make you better math learners. But this is the end of our 4.5 in Big Ideas, or our little lesson for today, and I'll catch you guys later.